Successful ecological agriculture begins with the soil. If you feed the soil, you'll feed the plants. A plant fed properly will be strong, attractive, and better able to fend off pests and diseases. Here at the UCSC Farm and Garden, compost is a key ingredient in the soil fertility management practices. This mound of compost here in Compost Row is made up of decomposing vegetation and manures. Adding this compost to plant rows will result in strong and attractive fruits, vegetables, and flowers. Additionally, the use of compost allows us to recycle solid waste and avoid the expensive landfilling of those wastes. And then finally, compost is very important in that it allows us greater independence from petroleum-based synthetic fertilizers.
This garden was sculpted out of a barren, infertile hillside comprised of a California chaparral plant community. It was essentially a soil low in organic matter, very high in clay content. Much like what you see here, not something you would associate with fertility. It was stiff, difficult to work with anything but a pickaxe. It has been transformed into this, a dark soil, high in organic matter content, 6-7%, capable of sustaining diverse cropping system. This was done by the use of compost in conjunction with French intensive double digging techniques. At the present time, this garden requires very little digging and a relatively low application rate of about 2 to 3 tons of compost per crop. This is a result of the cumulative effects of composting and sound soil management over the years.
Here at the UCSC farm, we have a sandy soil that has also benefited from the addition of compost over the years. Adding compost to a sandy soil will help its capacity to hold moisture and nutrients. Compost has many uses around the farm and the garden. We use it in our garden beds and in the fields. We use it around trees and shrubs. We use it as an amendment in planter boxes, and we sift it to use in our propagation mix in the greenhouse.
What is compost, and how do you make it, and why would you make it? Compost basically is the same thing as a natural process of breaking down of organic material. Any organic material, that is something that was once alive, has to break down to its final small molecular parts. Anything like straw, anything that was once alive, will break down to a soil-like substance eventually. In composting, when you do a compost pile, you are taking the same processes of microbial breakdown and speeding it up, giving it ideal conditions, and putting it in one spot. So the end product is something that you have access to, so you can use it when you want it and where you want it in your growing system. A finished compost looks like soil, basically. It looks like a rich soil, brown in color, dark brown, crumbly in texture, and very fine. A finished compost shouldn't smell like anything, or if it does, it should smell sweet. It shouldn't attract flies, and should basically look like something that you would like to have in your garden or in your planting mix. Compost added to your soil adds more things than its volume would indicate. Compost is a stabilizing addition to your soil. It has organic matter in it, and it provides aeration for the soil because of its fluffy texture. It also holds the nutrients that are already in the soil more tightly than the soil itself might. It provides the nutrients itself because, remember, it came from organic materials that contained nitrogen, phosphorus, sulfur, and all the microelements. So itself provides nutrients to the soil and basically provides an excellent habitat for beneficial microorganisms that are living in the soil that also release nutrients to your plants. So compost is sort of like the aspirin of the soil. It adds so many things. It really helps the soil's health along, and thus the health of the plants. What kinds of materials can you use to make compost, and how would you do it? Well, basically, because compost is derived from organic materials, you can use any organic material to make compost. It could be cardboard, for that matter. Cardboard used to be wood. It could be straw. It could be waste from your growing operation, old plants that you were unable to sell. Or it could be just about anything that you bring out of the kitchen, scraps from your dining room can be used in the compost pile. And basically, the trick to doing it right is getting the proper combination of all these ingredients layering them, adding enough water, giving them enough air, and letting them cook.
A compost pile is a home to millions of microorganisms. Bacteria are some of the first microorganisms to colonize an active compost pile. Bacteria are quite amazing in that they're able to reproduce at phenomenal rates. In fact, they reproduce at an exponential rate at the beginning of the compost process. The bacteria feed upon labile chemical compounds, and the energy released in the breaking of those bonds are the heat that we see in a compost pile, the steam that we see in a compost pile. These bacteria decompose the material with extracellular enzymes which are actually exuded outside of their bodies, attack the chemical bonds of the material and break them into simpler forms. Later, these bacteria are reduced in size and activity, and other microorganisms take over into the compost process. We have fungi and actinomycetes, which become very important players in the compost process. In fact, the actinomycetes and fungi are those gray or whitish filaments that we see in the compost pile themselves. We find the compost is cooler. There's less heat being generated, and at this point in time, other insects, larger macrofauna, meaning everything from beetles to centipedes, etc., are now colonize the waste and are feeding upon the waste of those dead cells of fungi and bacteria, as well upon other material which is still left following the compost process. At this point in time, compost generally cools down close to ambient temperatures, and we start seeing compost as mature.
Everything organic has a characteristic ratio of carbon to nitrogen in its tissues, ranging from a high of 500 to 1 for sawdust to a low of 15 to 1 for something like table scraps. A carbon to nitrogen ratio of around 30 to 1 is ideal for the activity of the compost microbes. We try to get approximately this balance by mixing greenish materials such as grass clippings or weeds, which are relatively high in nitrogen, with brownish materials such as hay, straw, or fallen leaves, which are relatively high in carbon. Often materials are not clearly green or clearly brown. You must experiment on your own with the materials that you have available to you to see what ends up being the best combination for you. We add to the pile a few shovelfuls of finished compost or soil, which acts as a source of microorganisms, sort of like you would add yeast to the bread to activate the recipe. Sometimes we add woody plant prunings, but these should be finely chopped or used at the bottom of the pile to create some air spaces. Ideally, we would thoroughly mix all the materials together. Complete mixing of ingredients results in hotter piles that decompose more quickly. Usually, however, we layer these materials because it's easier to do, and it helps in judging the right proportion of green to brown materials. Although we try to achieve a carbon and nitrogen ratio of 30 parts carbon to 1 nitrogen, we will make compost with a higher ratio, 50 to 1, when we don't have enough high nitrogen ingredients. These nitrogen deficient piles will just break down a little more slowly. Besides choice of raw materials, there are 4 factors important to consider when making compost: the surface area of the materials you use, the volume of the pile, the aeration of the pile, and moisture content of the pile. The surface area of the compost materials will affect the composting process. The more surface area available for the microorganisms to attach and digest, the faster the materials are decomposed. Ideally, we would chop our materials with shovels, machetes, or shredding machines to increase the surface area. This is very effective, but also very labor-intensive. If in your finished pile you see sticks still undecomposed, then you are not chopping your materials fine enough. The volume of the compost pile will also affect the composting process. A large compost pile will insulate itself and hold the heat of all this microbial activity. The center will be warmer than the edges. This heat produced by the microorganisms encourages even more decomposition. Here on Compost Row, we have long piles of 5 feet wide and 4 feet deep, which is ample for heat building and retention of heat. Piles smaller than 3 feet cubed will have trouble holding this heat. Piles larger than 5 feet cubed may not allow enough air to reach the microbes at the center, and ideally should be turned several times to aerate the pile. Air is important because it is necessary for the most efficient composting microorganisms to thrive. If air is lacking, a whole different set of microbes take over, and the compost heaps may give off unpleasant smells, and decomposition will slow down. We get air into the piles by loosening the soil beneath the pile, putting bulky material on the bottom, and turning the piles at least once. Moisture is important to the composting process. Compost piles should be moist but not wet. Like most living things, composting microbes require a certain amount of moisture to live. So to encourage them, moisture should be added evenly to the pile as it is made. However, like other air-breathing organisms, these microbes will suffocate or drown if inundated with water. Too much water will kill the microbes and thus the composting process, resulting in a soggy, foul-smelling pile. Try to keep the pile about as moist as a wrung-out sponge. Location of the pile is another important consideration. We protect our piles from extremes of wind and summer sun, which cause drying out, by locating them near a shade-producing windbreak of fruit trees, locust trees, and various shrubs. Through their roots, the windbreak plants absorb nutrients leached from the compost piles and return these nutrients in the fall in the form of fallen leaves. In the winter, these deciduous trees lose their leaves, allowing the sun to warm the piles. During the rainy season, piles are covered with tarps to protect them from leaching and saturation. Then time and temperature take over. When we use materials with the proper carbon to nitrogen ratio, provide a large amount of surface area and a big enough volume, and see that the moisture and aeration are adequate, we get a hot, quickly decomposing compost in 3 days. Our piles that are turned once yield finished compost in 4 to 6 months.
Here are 5 things to keep in mind for simple and successful composting. First of all, remember to get a good balance of carbon to nitrogen materials in the pile, that it's a good balance of green to brown. Second, keep it moist as a wrung-out sponge. Third, chop up materials to increase the surface area. Fourth, get a volume that's about 3 by 3 by 3 at the minimum. And finally, turn the pile at least once to aerate it and to troubleshoot any problems that might be happening in the pile.
Here at the Agroecology Program Farm, compost and composting is a key portion of the soil fertility management program. Adding compost to soil improves soil structure by increasing the aeration and increasing the soil moisture holding capacity. Additionally, compost replenishes the nutrient base of soil and reduces the amount of waste leaving the farm or home. Finally, compost has an important role in reducing the amount of energy that's required to both handle wastes and add nutrients to our soil systems.